Hello, geometry crew. We've got day 4 of our SAT unit, which is going to be going over solving proportions. So let's take a look at the first 4 examples. These are just straightforward proportions examples. Now in the first one, usually when we solve proportions, we just cross multiply and divide, or cross multiply and solve is what I like to say. If we cross multiply, we get 3x equals 96. And then divide by 3 on both sides, and we get x equals 32. All right, if we substitute it back in, should be the same thing on both sides. So 8 on 32 should be the same thing as 3 on 12. So 8 32nds is 1/4, 3/12 is 1/4, so those two are equal. Remember the reason why we cross multiply and solve is because of the algebraic steps that are happening here. So if I just rewrite the problem, if we want to solve for x, okay, we've got to get this thing out of the denominator, so we'd multiply by x on both sides, which cancels it out right there on this side. X divided by x is 1. And then if we want to get 12 out of the denominator, we would do the same thing. We'd multiply by 12 on both sides. And once again, 12 divided by 12 is 1. So that gives us that 3x equals 12 times 8, which was our 96. All right, just brief review as to why we can actually cross multiply and solve. All right, now we're just going to use it on the next examples. So in example 2, once again, we're going to cross multiply and solve. All right, so 4 times 24 is that 96 again. And now this is 3 times this whole quantity. So I'm going to put parentheses there and write it out. 3 times the quantity x minus 5. Now we've got to distribute. So if we don't include those parentheses, we're probably going to forget this step that we need to distribute 3 to both of these terms. So we get 3x minus 15, and then we got to solve from there. So add 15 to both sides. So if we add 15, that's going to give us 111 on the other side. Divide by 3, and we're going to get 37. Okay, and once again, we can always double check by plugging it back in. 37 minus 5 is 32, and 24 32nds is the same thing as 3/4. So that thing works. All right, let's take a look at 3. We're ramping up in difficulty each time we get to a new question. So if we take a look at this next one, we're going to cross multiply. Don't forget to include those parentheses because it's 7 times this whole quantity, which is x minus 4. All right? And that's going to equal 11 times this whole quantity, x plus 2. So now we just distribute. So 7x minus 28 equals 11x plus 22. And now we need to get our constants on one side and the variables on the other side. All right, so that's up to you how you do that. I'm going to get rid of the 7x, so subtract 7x on both sides. So that would leave a 4x on the right side there. And then if the x's are on this side, I need to get all the constants on the other side. So subtract 22. Oop, there we go. And we get negative 50. So 4x equals negative 50, and we can divide by 4. And remember, this says if necessary, round to the nearest tenth. So negative 50 divided by 4 is negative 12.5. All right, and example 4, last one, most difficult one out of these. We've got to cross multiply, and when we cross multiply here, we've got a binomial times a binomial. If you remember from day 5, we talked about factoring. When we multiply a binomial times a binomial, we've got a FOIL. All right, which means just distribute each one of these terms in one binomial to each one of the terms in the other binomial. All right, and then we cross multiply here, and we get 24. So when we FOIL, we got to multiply the first terms together. That give us x squared. The outer terms will give us negative 1x. The inner terms, 9x, and then the last two terms, negative 9. All right. Now now it's time to combine some like terms. So we got x squared plus 8x minus 9 equals 24. But we want to set this thing equal to 0, so we have to subtract 24. And if we do that, we're going to get x squared plus 8x. And when we subtract 24 from negative 9, we get negative 33. Now from day 5, we remember that if this is factorable, and we're going to suppose that it is, it's just a binomial times a binomial. Right, and we're going to use that guess and check method. So x squared, the only way we're going to get that is x times x right there for those first two terms. And then to get that negative 33, that's the result of multiplying the last two terms. So different ways we could get negative 33 would be, of course, negative 33 times 1 or 33 times 1. Well, what we're looking for is the outer and inner parts of FOIL to give us 8x. Obviously, 33 and 1, whether one's negative and the other one's positive, it doesn't matter. That's not going to give us 8. All right, so what we're looking for is a different two factors. Okay, so 11 and 3 comes to mind. But obviously, this has to add up to be positive 8. So the one that's got to be positive is the bigger one. These two multiply to be negative 33, and the outer and inner, the sum of the outer and inner products of FOIL give us positive 8x. Now let's set each one of these factors equal to 0. And now let's solve for x. So we get negative 11 and positive 3. All right, in the last three examples, and I'm going to clear the board and move on. In the last three examples, we're talking about word problems. So these are problem types that we would normally see on the SAT or even the ASVAB, the military entrance exam. You know, they love proportions, you know, problems like that. So we're going to take a look at 3 of them. So in 5, we have an airplane traveled at a speed of 600 miles per hour for 90 minutes. How far did the airplane travel? Okay, there's many different ways we could figure this out, and there's always usually an easier way that we could figure this out. But I'm going to use kind of what we've been talking about with proportions to figure this one out. First thing that I notice is that the units aren't the same. We got miles per hour here, and then we got minutes. So we got to convert one into the other. All right. Since the answer is in terms of miles, I'm actually not going to touch this. So this is the one that I'm going to change, the 90 minutes. We want to figure out how many hours is 90 minutes. Now, the answer might already be appearing in your head, but one thing we know for sure, or we should, is that there's 60 minutes in 1 hour. Now, obviously, we're trying to figure out how many hours is 90 minutes. When we're setting up this proportion, we got to have the same units on the same side of the fraction. Okay, so our minutes are in the numerator here, so we're going to put the minutes in the numerator on the other side of the equation. So we want to know how many hours 9 minutes is, and we could just set up this proportion and solve. All right, so when we cross multiply, we get 60x equals 90, and then we're going to divide by 60, and what we get is 1.5. All right, so 90 minutes is 1.5 hours. Awesome. Now that we've got this in terms of hours, we can set up another proportion here. All right, so 600 miles per hour literally means 600 miles divided by 1 hour, or 600 miles in 1 hour. Okay, so now we've got our hours here. We've got to write in equals. So I'm going to put 1.5 right there on the same part of the fraction as hours are on the left side of the equation. So we got hours in the denominator here, hours in the denominator here. And there's our variable. Well, we already used x. Let's say y. All right, so now we're just going to cross multiply. So that's just 600 times 1.5, right? And that gives us 900. So 900 miles is how far this plane is going to travel. All right, so we set up two proportions to solve, and sometimes that's necessary. Obviously, if we already knew that this was 1.5 hours, that skips that step. Okay, and then all we have to do is 600 times 1.5. All right, and that's fine. There's always shortcuts. All right, let's move down. Go to the next one. So this one's an interesting one. It says Dan is preparing for a 10-mile race. He will run the first 5 miles at an average speed of 6 miles per hour, the next 3 miles at an average speed of 8 miles per hour, and then the final 2 miles at an average speed of 10 miles per hour. Really kicking it in gear there. How many hours, rounded to the nearest hundredth of an hour, will it take Dan to run the race if he follows his plan? So I'm just going to chart the course of the race here. Okay, not the literal course. I have no idea where Dan's running. All right, but let's just say, okay, start to finish, here we go. That's the 10 miles. All right, for the first 5 miles, okay, Dan is going to run at an average speed of 6 miles per hour. So that's phase 1 here. Now in phase 2, the next 3 miles, all right, Dan's going to run at 8 miles per hour. And then phase 3, the final stretch here, the final 2 miles, is going to run at 10 miles per hour. All right, it's nice we've got some of this information, but what we're really concerned about is the time. It says how many hours, how long will it take? So we want some equation in terms of time to figure out, hey, what is the time that it's going to take Dan on this stretch, and that stretch, and this stretch? Now, with all this information given, miles representing a distance, miles per hour representing a rate, this brings to mind distance equals rate times time. Okay, so this is an equation that we should know. It's one of the fundamental equations in terms of real-life examples that we have in algebra. All right, so we should know distance equals rate times time. Now, if we solve this equation for time, we would just divide by r on both sides. So what we get is time is distance over rate. So we can figure out how long this first phase takes if we just have the distance and the rate. We know what this distance is, 5 miles, and we know what the rate is, 6 miles per hour. And instead of MPH, I'm going to just write it like this. Okay, and this gives us the time because miles divided by miles, those are going to cancel out. And when we're dividing by h here, it's actually going to move to the top. So we're going to get our hours. Okay, so that's 5/6 of an hour that's going to take him to do the first stretch. All right, and then in the second phase, our distance is 3 miles. Our rate is 8 miles per hour. I know that looks like a U. It's supposed to be an I. And then on the last stretch, the final 2 miles, Dan is going at 10 miles per hour. Not messing around, not playing any games anymore. All right, so in each one of these, we get the time in hours. Okay, that's 5/6 plus 3/8 plus 2/10. And if we round that to the nearest hundredth like it asks, we get 1.41 hours. Just about 1.5 hours to run those 10 miles. All right, and the final question. This is about exchange rates. So the current exchange rate right now, as of March 31st, 2020, for US dollars to rubles is $25 is equal to 1,959 rubles. All right, if Robert travels to Moscow with $500, we want to know how many rubles that is that he could exchange it for. All right, so use some purple here. This one is actually just a straightforward proportion. So this is one ratio that we know. $25, I'm just going to write a little dollar sign, is 1,959 rubles. I'm just going to write a little R there. Remember, we want the units to go on the same side. All right, so when he travels to Moscow and brings $500 with him, we want to know how many rubles is that. So we're going to cross multiply. It's 25x equals 500 times 1,959. We get a big number there. It's 979,500, and then divide by 25 on both sides, and we get 39,180 rubles. All right, folks. All right, that's that. If you have any questions on any of these problems, make sure to email me. The homework will be posted at the same time as long as the answers, and if you have any questions on those, make sure to give me a message. All right, thank you and have a good day.